We're going to look at this question today. When you get a question like this in physics, the most important word in this question is constant speed. The fact that this object is moving at constant speed implies that there is no acceleration. Acceleration is 0 meters per second squared. That then implies that the resultant force on this object is 0 from Newton's second law. Okay, the forces are balanced, and we're going to use this principle to do this question. I think when you look at the mark scheme, they've gone through the energy route. You could do that, but the easy method, identify all the forces. So the first force that we've got here would be the weight. So that's mg. But the object is moving along the plane. And if we look at it, the question says here it's been dragged. So it's going up with a constant velocity. If that was acceleration, I'll be doing 2 arrows. So we'd like to work along the plane. So mg is a bit of a problem going vertically down. So what do we have to do? We have to resolve it. So the first one along the slope would be mg along the slope, remember, sine 24. We've done that before already, right? And then the other one would be mg cos 24. We ain't going to use that, so that's not really important because it's not acting along the plane. So that's force number 1. Force number 2, we've got a tension here, a tension of 350. Again, if we were to resolve that, we will get this as tension 350, and that would be sine 30 degrees. Not interested. These two forces actually would balance each other because the object is not traveling in that direction, it's traveling 90 degrees to it. Therefore, that implies that this and this are equal. Okay, right. The one that's of interest to us today is this one. So that's 350 cos 30 degrees. So those are all the forces. However, in the text, you're told determine the friction between the crane and the surface of the ramp. And we're going to use a different color for that. So we could use green. The object is going up. Friction always acts in the opposite direction. So friction, I'm going to put it, acts in this direction. I'm going to label that as force. And like we said earlier, because it's moving at constant speed, that means that the forces are balanced. So the force going down should be equal to the force going up, which means F sine 24, where is it? No, that's mg. mg sine 24 plus F should then be equal to the upward force, which is 350 cos 30. Cos 30 is root 3 over 2. That's 0.866. Multiply that. That gives you around 303. M is given, so that's 50. Multiplied by 9.81. Multiplied by sine 24. That gives us around 103 plus F. So F approximately gives you around 200 Newton. That's the easiest way to do it. If you do look at the mark scheme, they've gone through the route of potential energy, meaning that if this object moves this much, they try to work out the potential energy here, but then because it's not given a vertical distance, they resolved it. I think that's the easiest way. Okay.